I am Aditya Dua, and in this video I am going to explain CPU.hdl, how it is working and what is the functionality, and we'll also be explaining the code line by line. The API of the CPU chip is in three input pins including INM16, which is input M of 16 bits, the 16-bit instruction pin instructing what task to do after the decisions on performing the task. After that, reset pin is for the program counter, which is going to take input as reset and will give instructions to the ROM to set the control bit. The output pins include outm, rightm, addressm, and PC. The outm is 16-bit output and is the output of CPU and acts as input of memory, which will then save, read, or write the instructions inside it. The rightm output of CPU works as load for RAM. The addressm output is for telling where to write the memory inside of the RAM. The PC15 output goes in as input for ROM 32K for telling which instruction to carry on and where to shift the control. The diagram on how inputs are taken in by CPU and outputs given by the CPU are used is given in the word file I used. After the discussion of input and output pins, the part of the CPU will be discussed now. The NOT gates are used to check whether if the instruction is A instruction or a C instruction. To check that the most significant bit is negated in the first NOT gate and giving out as A instruction. In the second NOT gate, the output of first NOT gate is negated to give the output as C instruction. The AND gate is then used to store the output in some register that is either A or D. Firstly, the inputs are taken in, and if the input is a C instruction and the instruction 5 bit is 1, then the output is stored in the A register. The MUX16 is used to select what should be stored in the A register among the inputs as instruction and output of its ALU, with the selection pin as ALU to A, which is the output of the and then the output is given as A register in. Then the OR gate is used to determine the load bit for the A register. Then the built-in A register takes in input from the output of MUX16 load as load A, which comes from the OR gate. After this, a MUX16 is used to select between the inputs which comes from either D register and A or M register to give an output for the memory. An AND gate is then used to determine the load bit of D register to store the ALU output in the D register. The AND gate checks both conditions, and if those are true, the output will be stored in the D register by the input. It checks whether it is an C instruction and the fourth bit of instruction. Then the inbuilt D register takes in input as ALU out, which is the output of ALU. The load is out load D, which is output of the OR gate. Then the built-in ALU is used, which has 6 input control pins which help in computations. The computed result is given out as ALU out. It also gives ZR out and NG out to determine the result whether it is positive or negative and 0 or non-zero. Then we use two OR gates and an AND gate to determine the data to write in data memory or not. First, OR gate gives the address of RAM location, which is 14-bit, where the output of ALU is written, and the next OR is used to give the value that will be written specifically in the memory. Then the AND gate gives an output as write M, which helps in writing the location which is specified by address M. After that, the AND gates give an output as write M, which helps in writing in the location which is specified by address M. The two AND gate gives the condition as JEQ and JLT for the program counter. JEQ is jump equals to and JLT is jump lower than. Then the three lines of code or not and gates gives the JGT condition. JGT condition is jump greater than. If the output is positive, then the program counter would jump to address specified by the A register. By the two OR gates and the jump conditions, the PC is made to jump to the address specified by the A register. The OR gate firstly takes in JEQ jump equals to and jump lower than, giving out jump lower than equals to. And then this jump lower than equals to is taken in by the other OR gate with jump greater than to give jump to A, which at the end means that if Even one of the jump conditions is true, then the PC would jump to location specified by the A register. And if the output is false, the PC would be incremented by 1. Then to load the PC, the inputs C instruction and jump to A are taken and both of them are true. This will satisfy the AND gate. And then the output will be true, which means the C will be loaded. That is, the program counter will be loaded. If no jump is taken, the value of PC is incremented by 1, and then this is done by negating the PC load output. At the end, the PC takes in input as A out, increment as PC INC, load as PC load with reset pin, giving out PC as output, which goes in ROM 32K. With this, the HDL code ends, and thank you.